Hello, baby.
Let's get our feet wet solving these exponential equations. Now, I'm going to show you a way that's going to work obviously for the problems I'm showing you here, but I must be honest, it's not going to be the way we're going to use at the end of the semester with logarithms and such. Okay, don't let that scare you. But I tell you that because I want you to pay close attention to the reason we're doing this, and that is to review the rules of exponents. Okay. The facts about exponential functions are, number one, if we have something of the form y equals b to the x, b has got to be more than 0. Can't be negative.
Oh, yes.
If it was negative, it would yield non-real answers because you'd have to take a root of a negative number. Okay?
Oh, very bad. Definitely unacceptable.
And that's not very useful, non-real answers. So don't worry about b being negative, that's for sure. If b is 0, if you raise 0 to any power, then y will always be 0, won't it?
Boring.
So if it never changes, that's not very exciting, so we're not going to have that happen either. B can't equal 1. Well, it could, but if it did, 1 to any power is always 1, isn't it? And that would be...
Boring.
So that's not going to change either. So you don't have to worry about b being 1 either. So basically, we're going to look at the base, b, being numbers larger than 0, but not 1. The property we're going to use today,
Code red. Repeat. We are code red.
and the most important fact about exponential functions is if b to the x equals b to the y. Now the bases have to be the same for this to work, but if b to the x equals b to the y,
Hey, this is great, man.
then we know x equals y. And we can use that to solve equations, and we're about to do it.
Allow me to demonstrate.
Let's solve this. Now, we've got 6 to the x equals 36. Obviously, the bases are different.
Prepare to be astonished.
So let's create similar bases.
Making copies.
We're going to rewrite this equation somehow with a common base. Now, you see how the right side could be written with a base of 6. 36 is 6 to the 2th, isn't it? So if we write it 6 to the x equals 6 to the 2th with common bases, well, now we can use our property.
Okay.
X must be 2. If 6 to the x is 6 to the 2th, x must be 2.
Do that again.
Let's try another. Now, the hard part is coming up with that common base. Let's see. Look for
Copies.
a common base. What would be a common base that we could rewrite 64 and 16? Now, practice makes perfect on these. I smell 4 this time, because 64 is 4 to the 3rd, isn't it? And 16 is 4 to the 2th. But we have to remind ourselves of the rules of exponents. If we rewrite 64 as 4 to the 3rd, the rules of exponents tell us that 4 to the 3rd to the x is, well, we multiply exponents, don't we? Is 4 to the 3x. Now, we've got each side with a common base. 4 to the 3x equals 4 to the 2th.
Hey, this is great, man.
And 3x equals 2. Now, we're not done yet, but we have lowered the x down to a base level, if you would, and we can solve it by solving for x by dividing by 3 to both sides. And x will equal
Brilliance.
2/3.
Sheer unadulterated brilliance.
Okay? Note how we're reviewing the rules of exponents. And in fact,
And you're going to do it because I said so.
we're going to review it as we check this answer. What is 64 to the 2/3 power? Of course, we hope it's 16. Remember how to do this?
Certainly.
Well, 64 to the 2/3 is 64 to the 1/3 squared, or 64 to the 1/3 times 64 to the 1/3. Recall that you add exponents. Now the 1/3 power, what does that mean, remember?
Oh, yes.
The 1/3 power means the cube root, the third root. So 64 to the 1/3 is really
I know you are, but what am I?
the cube root of 64, which is 4. And now we raise 4 to the 2th,
You're absolutely correct.
and we've checked it. Okay, let's do another one. Recall that our method is to look for a common base. Now, what do you smell this time? 9 to the 2x plus 1 and 81. You know you smell 9. Let's rewrite 81 as 9 to the 2th. Now, if 9 to the 2x plus 1 is 9 to the 2th,
Hey, this is great, man.
then 2x plus 1 must equal 2. We still have to solve for x, but we're well on our way. Let's subtract 1 from both sides, and then divide by 2 both sides, and we get x is
Genius. That's what it is.
x is a half.
Genius.
Now that wasn't that difficult. Let's take that half.
Because I said so.
Now let's check it, not because I said so, but hopefully we can use the rules of exponents to do this. This one's not that difficult. If I replace x with a half, 2 times a half is 1. And 1 plus 1 is 2. And 9 to the 2th,
Yeah, baby. Yeah.
it checks, is 81. Now we've got more exponent rules to review. So let's do another.
I'm trying to think, but nothing happens.
This one looks a little bit more difficult. It's got a reciprocal. I'll give you a hint. 1 over 27 is 1 over 3 to the 3rd. So the common base we're going to use is 3. 1 over 3 to the 3rd, isn't that 3 to the minus 3rd? That's what negative exponents do. So now we have a common base. 3 to the minus 3 equals 3 to the 2x. And we can use our property,
Hey, this is great, man.
minus 3 must equal 2x, and solve for x by dividing by 2. And we'll get x equals
Correct, boy wonder.
minus 3 halves. Now dare we take minus 3 halves
Yes, you're in deep do now.
and put it back in and see if it works. See if it equals 1/27th. So instead of x, I'll put minus 3 halves. Now 2 times minus 3 halves is minus 3. And as we've said before, 3 to the minus 3 power, that means reciprocate 3 to the positive 3 power. So 3 to the minus 3 is 1 over 3 to the 3rd, which is 1/27th. How about that? Let's do another one. Practice makes perfect. Okay, we're going to look for a common base. Now look at this. What common base would you use here? What number can you raise to a power and get 32 and also get 4? Well, it's 2.
Oh, yes.
32 is 2 to the 5th, and of course 4 is 2 to the 2th. We got to recall our rules of exponents here because we still don't have exactly a common base. What are we going to do with that 5 and that x? The rules of exponents tell me that I have to multiply in this case. So I have 2 to the 5x equals 2 to the 2th, and now I can use my
Hey, this is great, man.
my property and then solve for x by dividing by 5. And x is 2/5. Of course,
Mayday. Come in, Star Command. Send reinforcements.
we're gonna have to check it, but don't worry. we can do this. Let's take x and replace it with our answer, 2/5. Now recall how to do this. Do a little bit at a time.
Yeah, I know that, dude.
Okay? We'll do 32 to the 1/5 and, square it. 32 to the 1/5 squared is 32 to the 2/5. Okay? 32 to the 1/5, what does that mean? 32 to the 1/5 means the 5th root of 32. Now you need to understand, what is the 5th root of 32? What number to the 5th power equals 32? I may be spoiling you a little bit, but it comes out even. It's 2. Okay? Now I'll take that 2, raise it to the 2th power, and it looks like it works. I get the other side. I get the 4. Okay? I don't suppose you're noticing how I'm sneaking in these little factoids about exponents, such as negative exponents and fractional exponents. Well, I have another for you. Let's look at this multiple term exponent. 125 and 25. Now take a good sniff and tell me what's going to be the common base here. Well, hopefully practice is made perfect and you smell 5. Let's rewrite 125 as 5 to the 3rd and 25 as 5 to the 2th. Now we'll have to use our rules of exponents to kind of simplify the left side. I'm going to multiply the 3 times the x minus 2 and get 5 to the 3x minus 6. Now I can use my principle, because I actually have common bases, and just rewrite that 3x minus 6 equals 2. Now let's solve for x by adding 6 to both sides and dividing by 3. And we'll get x is
Baby, you're the greatest.
x is 8/3. Now,
Because I said so.
another way to check this, of course plugging in 8/3, is to correctly use your calculator. Now, it's important to note that if you type 125 to the 8/3 minus 2, you better always put parentheses around the complete exponent. Always put parentheses around the exponent, okay, to force the order of operations that you want. And son of a gun, if you do it correctly, you will get 25, and it does check. But that's a thing I wanted to remind you of. That's a very common mistake. People forget to put parentheses around exponents. If we didn't put parentheses there, I hope you appreciate that it would raise 125 to the 8/3 power, get an answer, and then subtract 2 from that. And that's not what we want here.
Does everybody know what time it is?
Okay, let's go try and practice these. Look for that common base. Go do the homework.